Okay. There should be some derivation, very important, which are not found in many sources, that is time independent Schrödinger wave equation. Okay, we normally get time dependent Schrödinger wave equation, but it is very rare question, that is time independent Schrödinger wave equation. Very rare. Okay. Derivation of Schrödinger wave equation, time independent. Okay, remind it. Consider a stationary wave that should be associated with a microscopic particle, that as for example electron, traveling in the positive x direction with precisely known momentum px and total energy capital E. Means stationary wave means which that should be stationary, like for example like that. With microscopic particle, microscopic mean that is electron, proton, neutron, like subatomic particles which are size is very small. Micro means size is very small and macro means size is much bigger. Okay, so microscopic particle, that is very small size particle. So consider a stationary wave that is associated with a microscopic particle traveling in the positive x direction. Okay, with precisely known momentum, that is must be px, that is vector quantity, and total energy, that should be E. The wave equation of this stationary wave in terms of coordinate x is given by, that is psi equal to a 2 pi x by lambda. Psi equal to a sine 2 pi x by lambda. Lambda is the wavelength. Okay. Okay, is the amplitude. That should be, if their wave is there, if their wave is there, that is these two drops or these two, the distance is lambda, wavelength, and their height, that should be called amplitude. Okay. So psi equal to wave function. X is the displacement of wave function, that is must be in x direction. Okay, that is called displacement. Okay, A is the amplitude or maximum height of the wave, and lambda is the wavelength of the wave. Okay, psi is the wave function, x is the displacement of wave along x-axis, and A is the amplitude, maximum height of the wave, lambda is the wavelength of the wave. Okay, that is differentiating the equation, d psi by dx. As we know, that is by differentiating this, the psi equal to a sine 2 pi x by lambda, what we get, that is must be 2 pi by lambda, that should be a constant quantity, that should be come first, this. Okay, then a also the same constant quantity, that should become first. 2 pi a by lambda, that should become first. Then we consider sine 2 pi x by lambda, their derivative we get, actually the derivative of sine we get cos. Okay, if we differentiate sine we get cos. Okay, so due to this we get cos 2 pi x by lambda. So overall we get d psi by dx 2 pi a by lambda cos 2 pi x by lambda. Okay. Okay. Next we get differentiating with respect to x again, that is must be double differentiation. Okay, that is d square psi by dx square, that should be, we know there must be again 2 pi by lambda 2 pi a by lambda, that should be again come first. Okay, so ultimately we get 4 pi square minus 4 pi square by lambda square. 4 pi square by lambda square, and a also again. Okay, the a should be come again. Okay, a sine 2 pi x, that is minus of a sine 2 pi x. Okay, okay, actually this a is amplitude, is a, there should be a is there. Okay, okay, I think a is not considered as a constant. A is amplitude. This is also a term as a wave function. Okay, I think. Okay, not of that. A is a also come here. Okay, so a, this whole term, that should be considered as psi. Okay, there must be, I think for derivation, a is not considered as a constant. A is considered as a wave function, that should be intact like this. Okay, so a is not come first. Okay, so overall a sine 2 pi x by lambda we calculate, that is psi. Okay, okay, that is, now we get, that is d square psi by dx square equal to minus 4 pi square by lambda square psi. This equation is applicable to all microscopic particle, that is must be electron, that is for proton, that is for photon, that is must be neutron also. Okay, according to debug, we knew that is h equal to lambda equal to h by px, or lambda equal to h by p. P means momentum. Okay, momentum. H is the Planck's constant. Okay, and as we the wave go in plus x direction, so we can say that is px. Okay, so that's why lambda equal to h by px. And we also know that is p equal to mv, that is mass into velocity. So by this way we can say that lambda equal to h by mv. Lambda equal to h by mv. Okay, where m equal to mass of moving microscopic particle, v is the velocity of particle in x direction. Okay, so squaring the two equations, that is lambda square equal to h square by m square v square. Lambda square equal to h square by m square v square. Okay. Okay. Now, they are squaring, we get what? That is minus, that is lambda square equal to h square by m square v square. Okay. Now, that is overall squaring, 4 pi square. What we get? 4 pi square, this minus 4 pi square by lambda square. So 4 pi square already there, but lambda square, the value of lambda square we put it. That is lambda equal to, we get, that is h square by m square v square. That we put in that equation. So we get d square psi by dx square equal to minus 4 pi square m square v square by h square, that should be equal to psi. M square v square by h square, that should be the value of 1 by lambda square, sorry, 1 by lambda square equal to m square v square by h square. Okay, total energy means what? Total energy means that should be kinetic energy plus potential energy. Ke means kinetic energy, P means potential energy. And as we know, that is kinetic energy is equal to half m v square. Kinetic energy equal to half m v square. And potential energy, that is suppose capital V. Okay. Now, that is half m v square, that is kinetic energy equal to E means total energy minus potential energy. That is half mv square, that should be half mv square is the kinetic energy equal to E is the total energy minus B means potential energy. That is kinetic energy equal to total energy minus potential energy. Okay. So mv square equal to 2E minus B. MB square equal to E minus B. So by this way, we can derive in place of M square B square, in place of this value, we put in this. In place of MB square, we get MB square, we put 2 into E minus B, we get ultimately d square psi by dx square equal to minus 8 pi square M E minus B by H square psi. This square psi by dx square equal to minus 8 pi square M E minus B by H square into psi. Okay. Ultimately, we add this term in this side. So ultimately we get that is d square psi by dx square plus 8 pi square M E minus B by H square psi equal to 0. That is also Schrödinger wave equation. That should be derived by the method of independent what? Independent, time independent. Okay. Okay. Equation is Schrödinger wave equation for was moving in one dimension. But if we consider in space that is x, y, z coordinate, that is, as we know, if this is y, this is x, and that should be the z, right? They are perpendicular to each other. Perpendicular to each other, right? That is, we can derive d square psi by dx square plus d square psi by dy square plus d square psi by dz square plus 8 pi square M E minus B by H square psi equal to 0. Okay. Now, we term as that is delta square. Means what? That is delta is a Laplacian operator. Laplacian operator. Delta is a Laplacian operator. Okay. Now we consider what is Laplacian operator. Okay. Okay. That should be del by del x square plus del by del y square plus del by del z square. Okay. Del square by del x square plus del square by del y square plus del square by del z square. That should be delta. Plus 8 pi square M by H square E minus B into psi equal 0. This whole term we can say that is H cap. That is Hamiltonian operator. That is Hamiltonian operator is the operator of total energy in quantum chemistry. Hamiltonian operator is nothing but that is a whole total operator of the total energy in quantum chemistry. Okay, that is H cap psi equal to E psi. Now, expression of Schrödinger wave equation using Laplacian operator. Same thing, that is we can derive it that d square psi by dx square by del square psi by del y square plus del square psi by del z square plus 8 pi square M E minus B by H square. So the value whole, that is delta square by del x square plus delta square by del y square, delta square by del z square, the value is del square, that is Laplacian operator square psi plus 8 pi square M E minus B by H square psi equal to 0. Okay. So here that is Laplacian operator square equal to del S square del x square plus del S square del y square plus del S square plus del z square. So ultimately we get, we consider overall, that is by, that is dividing both of side. Okay. That is by this way we can derive this also. Minus H square by 2M del square del x square plus del square del y square plus del square del z square plus B psi equal to E psi. First we consider, that is they are all this term that should be divided both sides. Okay. Now the question is how this term is we get. How we get this term? That is nothing but this equation that should be divided by both sides, that is h square by 2m. That should be multiplied by h square by 2m. Okay. H square by 2m. I think h square by 2m, not like that, h square by 8 pi squared m. Okay. So ultimately we get, that is minus h square by 2m del square del x square plus del square del y square plus del square del z square plus b into psi equal to e psi. So we can put it the value, that is this Laplacian operator. Okay. So in the wave expression, that is must be by this way, that is must be del square psi plus 8 pi square m h square into psi minus h pi square m by h square b into psi. We can derive it from this. Okay. By this way we can put it in the that is other side of the equal to. Okay. Then dividing 8 pi square m by h square. Now we get this value. Okay. So by this way we can say the summary, that is time independent. So in the wave equation, that is if a stationary wave, that should be go in x direction, the amplitude a and the wavelength, that should be lambda, get psi equal to, ultimately by lots of derivation a sine n pi x by lambda. Okay. By this way we can derive, that is Schrödinger wave equation. So in the wave equation, that should be there. So in the wave equation, del square by del x square plus 8 pi square m e minus b by h square into psi equal to 0. We can derive also, that is must be del square del x square plus del square del y square plus del square del z square, and that is also in 3-dimensional. That should be 1-dimensional, and that should be equal to del square. Okay. And always remember, that is ultimately we get e psi. The overall value, that is must be del square plus 8 pi square m by h square e minus b whole term, that should be h. Okay. So by this way we get the new operator, that should be h cap, that is a Hamiltonian operator. Hamiltonian operator. That should be nothing but, that is signify total energy. Okay, in quantum chemistry. Okay. Okay.